Then we should consider the equilibrium of forces and calculate the depth.
Okay. So if depth is given, should be the reverse. Got it? What is actual punching stress? What you're going to get from top, and what is your resistance? Got it?
Yes.
So this
Yes.
check is to be done. So what is coming from top should be less than what is being supported from bottom. Is it? At
Yes.
equilibrium, you're going to equate these two for getting depth of our footing. So if depth is assumed, you are supposed to see that your resistance is more than your action. Got it? So next one would be your development length check, and after that, this should be your bearing check. So
Yes.
if your column section is very, we mean very weak in or very weak in transmitting this onto a footing, now you go for a special design system, what we call as double bar system. So these double bars are going to transfer the extra
Column.
loads, extra column loads, where column is not transmitting this to our footing through bearing. Got it? So
Yes.
we have, and I have given you notes regarding different designs like rectangular footing, sloped footing. I have given you pedestal. Is it pedestal
Yes, sir.
design?
Yes, sir.
Choose your running.
Yes, sir.
The concept is one and the same, all these things. Yeah. After this, extending my study now, like I want all of you to have small programs of your one-way shear, two-way shear in your mind. So in coming days, if you do go for the designing of all these things, you go for one-way shear check, two-way shear check. Now this should run. అర్థమవుతుందమ్మా
Okay, sir.
అందరూ లెనిన్ కాదు లెనిన్ హరికృప ఫిర్దోస్ కాకుండా అందరూ ఐ వాంట్ కన్ఫర్మేషన్ ఫ్రమ్ అదర్స్ ఐ వాంట్ కన్ఫర్మేషన్ ఫ్రమ్ అదర్స్ విశాల్ రాజేష్ నజాముద్దీన్
Yes, sir, understood.
there is no fun in coming and muting your mics without responding.
Yes, sir, we are getting.
Yeah, you should tell me.
I'm outside, sir. I'm coming to college to pay the fee. So
Now,
that's why I'm
what it
using
may
my.
be, I asked you whether you understood this or not. You should give a
Yeah,
response.
understood, sir.
Yeah, that you should respond.
Okay.
Yeah. Am I extending our study? You're getting me?
Yes, sir.
Yeah. Extending our study. Can you see my PPT?
Yes, sir.
Yeah. Now, whenever you come to real time isolated footing, a 3D animated picture is shown to you. You're following?
Yes, sir.
Yeah, this is your reinforcement placed in one direction, reinforcement placed in the other direction. Okay, now this is your column reinforcement and this is your formwork for your columns. Now this is an example like how your design would look like. And this is real-time drawings what you are supposed to issue to your site, giving all the details. I'll share this PPT after I complete this presentation, mostly by tomorrow evening.
Okay, sir.
Okay, sir.
Just have a glance on it. Got it? Now how this should be done. What is a one-way shear, two-way shear, and all these things. Now this is typical academic example. Now whenever you go to site, now we won't give all these details. What will be given in the site, I'll tell you after we complete our unit 1 with all the real-time footing drawings. Got it? This is just to write in exams and to submit your assignments. Got it?
Yes, sir.
Yeah. Now before I get into next topic, like I want all of you to form into batches. Entamma total, what is class strength of yours?
19 members.
20 అనుకోండి. So I want you to get into 5 batches. You're following me?
Yes, sir.
So 5 batches ga form kandi. So each batch would be having 4 students.
Okay, sir.
Yeah. So as and when I complete unit 1, I want each batch of you to submit an assignment. And this assignment should be different from each group. You're following? ఒక గ్రూప్ చేస్తే సెకండ్ గ్రూప్ తీసుకొని కాపీ చేసేటట్టు ఉండకూడదు.
Okay, sir.
ఎందుకంటే వాల్యూమ్ వుడ్ బి వెరీ లార్జ్. మీకున్న ఫస్ట్ ఇయర్ ఎగ్జామ్స్ అన్నింటిలో ఈ స్టూడెంట్ కాంట్ డిజైన్ ఆల్ దీస్ థింగ్స్. సే ఇఫ్ ఇన్ ఫస్ట్ గ్రూప్ 4 students are there, like you want to have 4 designs: isolated footing, combined footing, eccentric footing, stiff footing, and then your sharp footings. So each one of you can take out one example and you will be solving this example. And the 2 designs of one group should not be matching with the other group. Plus, so this is what we do. You're following me?
Yes,
You're
sir.
following? Yeah. Yeah. At the end of your semester, after you complete your first meet, and then all these headaches, I want each batch of student to write programs for these designs, either Excel programming or if you want to use any other software. So I want you to cross-check your designs with any one of the software. So that report. You're getting me? Now this is a group assignment. You're following? అది మీ ఇష్టం. లైక్ సిఆర్ విల్ టెల్ మీ లైక్ ఏ గ్రూప్ లో ఎవరు ఉంటారని. గ్రూప్ 1, 2, 3, 4, 5.
Okay, sir.
సో లాస్ట్ గ్రూప్ లో 4 స్టూడెంట్స్ ఏమో వస్తారు. సో వి విల్ సీ వాట్ వుడ్ బి లైక్ దోస్ స్టూడెంట్స్. సో వాళ్ళకి వచ్చినప్పుడు ఐ హెల్ప్ దెమ్ యాజ్ ఎ ఫిఫ్త్ స్టూడెంట్.
Okay, sir.
అర్థమైందా? దిస్ నాట్ యువర్ ఇండివిజువల్ అసైన్మెంట్స్. Individual assignments కాదు ఇది. Now these are your group assignments. So after as and when I complete unit, I am going to give you loading conditions, nothing other than this, what you are going to see in real time field. నేను వీలవుతే ఒక బిల్డింగ్ డీటెయిల్స్ ఇస్తాను మీకు. స్టార్ట్ ఫైల్, ఇటాప్స్ ఫైల్, అవుట్పుట్ ఫైల్ మీకు ఇస్తాను. రియాక్షన్స్ ఫైల్. యూ ఫాలోయింగ్?
Yes, sir.
Yeah. అందులో so each one of you are going to pick out one column in one footing, and then you're going to design this. So assuming that the soil is very hard, you're going to get isolated footing. So this is very weak, and up you're going to get second footing. Got it? So likewise, in each condition you're going to get one footing. So I want you to design all these footings as a group. అయిన తర్వాత లాస్ట్ లో maybe last 1 month, you're following last 1 month, you can use any software for cross-checking these values, designed values. Excel programming, and then likewise you have many other softwares, foundation softwares. You following? So all these things should be done as a group.
Okay, sir.
Yeah, this is what you're going to do in next coming days of this interaction in this semester. Got it? Yeah. Now let us come to next slide. So the case of isolated footing, you're there. I want someone to be online, please. Since I'm in PPT mode, I can't see you.
Yes, sir.
Yeah. Yeah. Now the isolated footing, which was the very beginning of foundation, shallow foundation system, where we have seen only axial force acting on our system, and that too this was acting exactly on the column. But whenever you come to real time, now these cases are very rare, and this will be very for very small buildings with good and considerable amount of your SBC. So whenever you go for the isolated footing case, this is point where my mouse is getting pointed out. Now you see, like center of our footing and then center of our column would be matching, in which case you won't get any eccentricities in our column or eccentricities in our footing. Got it? So this is
Yes,
very,
sir.
very ideal case where for majority real-time present day scenarios, you won't find these cases, especially for small buildings. Small buildings, the normal urban buildings, you won't get these kind of isolated footings. So in our assumptions, now we have assumed that now soil pressure is uniform throughout our base of our footing. So which simplifies our analysis. So whenever you come to real time, now this won't happen. Now in which case you see some eccentricities in our columns. You're following eccentricities in our columns, and then eccentricities in our loads, and then our columns touching our property lines, our footings touching our property lines. Now all these conditions will lead to some moments along with our axial forces. The discussed conditions will start inducing some extra moments in our footings. In which case, no longer our base pressure would be uniform. Now this will be non-uniform. So this will be something like a case of direct stresses and bending stresses. So effect of direct stresses would be P by A on your soil, and effect of our bending moment, which we given as M, or P into E, would be M by Z. Got it? So whenever I start calculating stresses due to my direct load, axial load, and bending moment, this would be P by A plus or minus M by Z. Got it? So plus would be on the side where bending moment is going to act. Minus would be there on the side where bending moment is away from your leg footing. Got it?
Yes, sir.
Yeah, in which case you call this as Q max, and this is Q minimum. This is Q max, and this is Q minimum. So after proportionating of our footings, so next step from now onwards is to check this Q max and Q minimum. Now where Q max is P by A plus M by Z, and Q minimum is P by A minus M by Z. Got it?
Yes, sir.
So what you are going to do after proportionating our footing, you are going to calculate our Q value, and after this you are going to check our Q max and Q minimum. So Q max should be less than our SBC, and then Q minimum should not be negative. What happens if it is negative? Now in negative case, on the other side of our footing, so Q max, now this is going to be on compression side, on the other side, your bending moment is going to lift our footing. Since you have contact between your footing base and soil, now as and when moment is going to act on this footing, now this starts applying tension on your soil. So soil won't be taking any tension. Is it? Soils won't be taking any tension. So there should not be any tension failure of our soil. So maximum, this Q max should be equal to 0 at the not limiting condition. Got it?
Yes, sir.
Yeah. This is check what you're going to do after you proportionate our footings. Yeah. Now these are our cases. Like what happens whenever you go for uniaxial eccentricity. Uniaxial eccentricity. Now you can see now this is my centroidal axis of my footing. So due to some conditions, what are these conditions? In general, now you can't find columns exactly matching with centroid of our footing. So this is based on our architectural requirements or based on our site conditions. Got it? In majority cases, our column would be shifting towards right or towards left. You can see here. You're getting this? Now can you see this footing, enlarged footing?
Yes, sir.
Yeah. Uniaxial eccentricity. Now here is uniaxial eccentricity, where eccentricity would be happening in only one direction. So whenever you start doing this, now this is eccentricity along x-axis represented by Ex. Similarly, if your column Y, if your column is going to shift along y-axis, so this would be our Ey. Now you can see here. Now what would be effect of this? So column x-axis centroidal axis kaakunda, now this is going to shift towards right. Now you're following. So this is uniaxial moment. Moment acting in one direction, either mx or my. You following?
Yes, sir.
Yeah. Whenever you have biaxial eccentricity, so there will be chances when your column would be laying at corner of our footing. We'll see where you're going to get this case.